please.
So thank you for the introduction, Yin, and I would like to talk today about our EISCAT tools that we are developing and all the EGI services, especially EGI checkin that we are using and plan to use in the future. So the talk, I will just give a short overview. It's not very complicated. At first, I start with some EISCAT background, so who we are and how we are changing in the present and why we need EGI services for our future. Then I will present some connection between the EGI services and EISCAT services, at least the theoretical or desired one, how we want it to function in the future. And at the end, I will do a demonstration of the present status and development of EGI services, as well as our EISCAT tools, their functionalities, and what we are battling with at the moment. So that's a short overview. And EISCAT, as some of you know, some not, comes from European Incoherent Scatter. So EISCAT Scientific Association is a group that was founded in 1975 when people gained more interest into the ionosphere in polar regions and auroral regions, and they thought how we can use incoherent scatter to research various phenomena. In those times, you can see the photo from the first EISCAT Council meeting. Several countries came together and built the EISCAT, first EISCAT systems. And the aim is to provide access to radar in high latitudes and to provide highest technical standard for non-military scientific purposes. The headquarters are in Kiruna in northern Sweden, and since it's a while since the first operations began, we are building at the present a new system that will continue after our present system will basically stop functioning. So EISCAT community is a very large community. We have 6 associates in EISCAT Scientific Association, which are Norway, Finland, and Sweden, and China, Japan, and United Kingdom at the moment. And then we also have 4 affiliates. So researchers in these countries have their national communities, and they have a priority in gaining observational time on EISCAT facilities. Also, we have, this is an illustration from 2013, which was analysis of papers of authors and co-authors of EISCAT papers. So we have also a lot of users from prior member countries like France and Germany, and also from third-party users. So the community as it is already quite large and varied. These are our present systems. We have a VHF, that's this big white part in the picture, and UHF radar in Tromsø, which had also receivers in Kiruna and Sodankila originally. These are being nowadays closed, so tristatic measurements with the old system are not possible anymore. And then we have a system on Svalbard. This old system will slowly phase out as we are building new system, and the Svalbard system will continue for a while still. So this is just illustration how these measurements are working. So we are gaining ionospheric parameters with help of EISCAT radar, but because we have these dishes, they need to be physically moved if we want to change observational point, and that takes quite a bit of time in today's world. So a new system is being built. So it's known as EISCAT 3D, and this will be a phased array antenna system, which will be much more versatile because the direction of the beam and will be defined by software, and it will be much easier and quicker to switch also between observational directions and also between individual programs. It will have higher possibility to attract also more users. So and expand into new research fields. It will also be a tristatic system in northern Sweden, Norway, and Finland. And here you can see some present pictures from Skibotn site where the array is being assembled. And I've put also a bit more information. This is maybe not from the IT point of view, so interesting. It's just a lot of areas, a lot of arrays and sub-arrays, so there will be much more demands for computations and timing, and the system will be more versatile, but also more complex. When we try to compare what does it mean for us with the old system, the data acquisition will be much quicker. We will be able to run several programs parallelly. So the data amount of data will definitely have possibility to rise. So with all of these, a lot of things that are presently done manually will have to be done more automatically as well. So then we come to the topic of our data and operation. So of course, EISCAT has a data policy known as rules of the road. And in this data policy, we have also embargo times on observations. So countries, we have common programs which are usually very quickly accessible. Then we have special programs. And then also some researchers can have even longer embargo times if it's, for example, connected to a PhD thesis research or similar cases. So at the present, our data is accessible through EISCAT portal, which serves both as a way to request for observation time and a way to access level 2, so data from EISCAT present EISCAT systems. And then we have data available through Madrigal database, which offers the level 3 data, which is physical parameters, so the ionospheric parameters. Access to this is currently just monitored by like submitting, for example, on Madrigal, when one accesses first time, has to submit who and email address is accessing the data. At EISCAT portal, we have unregistered downloads of the level 2 data, but we are working also on EGI checkin, checked access that's in development. But in general, it means that once EISCAT 3D comes into operation, we expect the amount of data and also users to rise. And that will also imply that we need to change a bit our ways of storing and accessing the data. And also we need a better ways to ensure our data policy, like embargo times. And that is so this data is of course gained from the raw measurements with the use of some software. And at the present, EISCAT's main analysis package, Grand Unified Incoherent Scatter Design and Analysis package, which is commonly known between EISCAT users as GUISDAP, is the main way to analyze the data and gain the physical parameters. This package was developed by the community, and it's compatible with Linux environment where it can be installed without bigger problems, but Windows users and sometimes also Mac users can encounter problems if they want to use their offline their installation. So then we were thinking, since the behind of GUISDAP is it uses various languages. The core is in MATLAB, and then it uses models in C and Fortran. So it's not an easy fix to make it accessible on all platforms for all the users. But we became a part of another European project where we had a transnational access program, PTA transnational access program, and also during COVID times, there was a demand for remote access to do some research, and we decided to develop so-called EISCAT tools, which is basically Jupyter notebook environment, which includes GUISDAP and RTG, real-time graph. That's a program that shows the raw data. And then it includes all possible prerequisites for analysis tools like MATLAB, Julia, and Python. So users could use their already developed tools inside of the environment as well. But once we have this environment, we need somehow to also host it and somehow ensure the access that, especially for the TNA, that only those people who need this environment will access to it. So that was one thing how to think about it. So this was our present state. Basically, we had some user X who wanted to access our services, and the user X might have been or might not have been already part of EISCAT user community. The services we had for now was EISCAT data access, like Madrigal and the portal, and EISCAT operation, which is also portal web page where they request time for observation. In the past, it basically worked on identifying everybody wrote their names, contact, and in a small community, it can work quite well. Then, of course, now we have also the EISCAT tools, which we had have on one server at EISCAT, which we used for the TNA, and the same tools we have also on EGI notebooks. So this is one of the services we use from EGI, that they can be accessible for larger number of users. And then, of course, we have future services in development, which we are all the services we are planning for 3D. So some EISCAT 3D tools and some data access for EISCAT 3D and, of course, operation. So how to ensure that our user X will have access to those services they are, well, I don't want to say really entitled to, but like, for example, with the data, that they will not really be able to get the data that's under embargo, or we had to think. So, and that's where EGI checkin service is coming in. So to access our service, the user needs to identify themselves. So at least we know who he is. So that's done through identity providers which are connected to EGI checkin. So that can be something like EDUGAI network or institutional access or GUIDAP, but also like a Gmail. Each of them have some other level of assurance, which in the future we might want to request. For example, we want the users to use some official identity. So for example, like institutional access, then it has higher level of assurance than just maybe a Gmail. All these identities, of course, I think there is a way in EGI checkin how to connect various own identities, but that's not something I really went into. But this just tells us who is accessing the service. There is nothing to tell us, okay, so I know who it is, but what can this user access and what not? And that's where the EGI attribute management service Perun comes in. So EISCAT has a virtual organization on this in this Perun system, where we ideally can organize our internal community, and EGI checkin will check with the EISCAT virtual organization, and based on the placement in the groups, it will know to tell to our services where if this user can access to the given service he is trying to access. So what we need from users in our community is then user needs to register in our EISCAT virtual organization, and we need to have some group managers from the community that would ensure that they groups are the users that are supposed to be there and are supposed to have the access to whatever we enable for them. So this is like a theoretical background. Then the user just comes, and the user really just have some identity online, and he just really interacts with the service. The only request that's needed to be done is with the EISCAT virtual organization, and that's what the user will see. All the other things and checkings are happening behind the scenes. So this is the idea, and now I would like to demonstrate and show how it works for us. So I'll try to switch to my other tab, and I'll switch here. So if I'll switch here. If a user wants to access, for example, this is the portal web page, and the user wants to download some data. I already opened some April 2019 data. So they get the possibility to download at the moment, there are two possibilities: download with authentication and unauthenticated. But this is in development, so there are still many errors going on. So unauthenticated is sure, but it's already working also with the EGI account. So I might be already logged in. So if I press download, it will probably not ask me. No, it checked with EGI and realized that yes, because this is a person that's able to access this download. But if I would go to portal for, I should not be logged in here. So, and I want to download. We have a privacy from here. I need some data. Then it should want my authentication, which is checking. It's going through my personal Gmail now, so I can log in with Google. But since this email address is not in the virtual organization system, it should tell me that I am not authorized. So this service is only available to the EISCAT members. So for downloading data, which is freely accessible, you don't need much more just to become a member of the general member of the virtual organization. And now I would like to show the Perun. So once you log into Perun, I already pre-logged and prepared something. You will see your virtual organization management, and you can see that there are we can create various groups. So in the group members, everybody who applies to a virtual organization will end up in the group members. But then we can create, for example, specialized groups based on our national communities, or we have these two groups, eHub and Hub, which define at the present our access to either EISCAT tools at EISCAT headquarters, which is eHub, or EISCAT tools at EGI, EGI, which is Hub group. It's possible when we have some special groups of people. We can just create a new group, because then we can identify, okay, the people in this group have, for example, 2 weeks access to these tools because we are teaching them. So I can, for example, create a demo group, which would be and Perun has a very good possibility. You can see we have these application forms. So we can create an application form. This is our application form for the virtual organization. This one, if the user applies, is approved automatically. So users are becoming automatically part of the members group. But all the other groups, we need to manually approve the member. So when I create a group like demo, I don't have the application form, but if I already have it prepared in other group, it's very, very easy to just replicate the application. So we are trying to make some standard applications, and also notifications I can group from the same one. So setup which emails should be sent and to whom. We can also set up like the managers. So I can be manager of this group. This is me. So then now I would need to reload, but I will not. Then once the group is set up, I can either invite a member or add a member. If I'm adding a member, it's from those who are already registered in our virtual organization. If I'm inviting member, I will set, now I need to check. Oh, it will tell me. I will write to the person. The automatic email to a person will be sent with the link for a registration, and that now it said that user was invited. So we have no applications in this group, but I can show the other part of it. So this was me trying to download, but now I can go to this EGI email that invites me to register, and it automatically checks if I'm already part of the VO. If I'm not part of the VO virtual organization, it will at first register me to the virtual organization and then send my application for the group. We have also a way how to agree with our rules of the road when applying to the virtual organization, and this will be developed further. So then automatically we know whoever applied for be part of the organization agreed to observe our terms of use. So that was the first part, and this was the other. Well, I didn't change the application form. This was the one for the group. So once that it's submitted, it tells me I successfully submitted, and then the manager gets an email. It just came into my personal mail, and then on Perun, we should see that there is an application. We can also see in the EISCAT virtual organization that Maya was now became the member of the virtual organization. This one was approved automatically. So for the demo, the manager has to review the application, decide if, for example, if it's national communities, if they know this person, if what is the reason why they are applying, and then reject or approve. So let's approve. And now now Maya is in the demo group. So demo group has one member, and but the demo group doesn't really have any rights. So if I would try to access for example, EGI notebooks, I would not be able. I would need to be somehow associated with the hub group. So each of the groups have these relations. So the people doesn't have to be added to the group directly. We can just add the group we want to be associated with the rights of the other group to the relations. So in this case, I added demo to hub. So Maya will have access to EGI notebooks, but she is not associated with eHub group, so she will not be able to get to Jupyter EISCAT tools at EISCAT headquarters. So we can try if it's going to work. So this is the tab where Maya is present. So when she comes to notebooks, EGI.eu, she can continue with EGI checkin. Since we already used it, it should have remembered it. And since she is allowed to access EGI notebooks, she gets this offer of 4 servers for environments. So the EISCAT tools are in this EISCAT environment. So she can go and start up the server, and she accessed the EISCAT tools at EGI notebooks now. It takes a while. But as I showed, I added her to the hub group, and she should still not be able to get we have jupyter.eiscat.se, but she is not associated with that group on Perun. So it just checks with EGI and says, I'm forbidden to go there. So, but let's continue. So this is the part of Perun. So in Perun, we can decide which user have access to what, and that's why it needs careful management. Then the continuation is our tools. It's basically Jupyter notebook with GUISDAP and some other possibilities, like, for example, we have this desktop feature, which just simulates Linux desktop. Is for those who prefer to work with desktop environment, but we also have integration of MATLAB, since GUISDAP runs on MATLAB. But on EGI, they will ask for online license manager or network license manager. At our Jupyter hub, which I'll show here, we do not need license, like user do not need to give their license. We have with help of MathWorks, where we cooperate on development of these tools. We have a development and educational license for this. That's why we are limiting also a bit access to so we know who is using for what purposes our server. And the third possibility, since it's a Docker distributed Jupyter notebook, the third possibility is to run the environment also offline, locally. So one can start with help of Docker desktop. And those who are observant can see that this is my local host. So the one Docker image I'm using here should be the same as the one we have on EGI and the same as we have on Jupyter at EISCAT headquarters. But we don't know why. This is a mystery for us. It's the same image, but the Julia tool, Julia notebook doesn't show up in the online version. And we don't know to figure out yet why. But the same, when I run it locally, if I want to access MATLAB, it asks for license. So then it's enough to write license server address, submit, and he checks it out. It checks out, and one can start to use MATLAB. The environment remembers the license, so not each time it's necessary to write it. It is not necessary to write it each time. So this can take a little time. I hope it's working now. Maybe it's too slow. So the idea is that people can start GUISDAP either on the desktop environment or in MATLAB environment. The MATLAB environment has a bit advantage that if some debugging is needed, it's possible to do, and it's easier possible. So it depends, I guess, what people are used to look at the variables and stuff. But this takes a long time. I don't know what's wrong. On the desktop, it's basically work like with desktop. But if the MATLAB doesn't start up, okay, now. So after this point, for those who know GUISDAP, it's just the work as usual. They write the GUISDAP command and analyze command to open the graphical interface and can proceed with their analysis. There is one more problem we have at our EISCAT tools at our headquarters on our server. Recently, this desktop stopped to work. It's just a black screen. It has like a black overlay, so we don't see it. And we also didn't figure out what caused this change yet. So come on. I don't know, it's probably too slow today. But at least start with that. But I still don't see the prompt, so. Now he had something left in. Probably I wasn't very careful with finishing last time. Come on. Yeah, now. And so the advantage of this is that with the help of GUISDAP, users can reanalyze their data and change some parameters if they want to look at the data a bit differently, change, for example, integration time in comparison with the standard output of the analyze. So this is the graphical interface, which then loads the level 2 data and produces the analysis for level 3 data. So they can analyze it. They can also convert the math files to HDF5 files if they wish so. And then in the notebook, if they already developed some tools, we all are used to different things. There are scientists that prefer analyzing with MATLAB, others that prefer Python. And we have also a big part of community who really wanted to have Julia included in our tools. So we are trying to offer them possibilities to use their private tools or the community tools they developed in one place, just to import them and use them together. The advantage of this Docker, as we can see on the hubs as well, is that it can be set up for group use. So on the EISCAT EISCAT tools at EISCAT headquarters, we have a shared data folder. So when we were teaching a group of users how to use EISCAT, we could have just imported the data into this folder and everybody was able to access it. there are still shortcomings to this, but I think this is the main idea how we want to use. And now I get back to this slide, how we want to implement EGI. And I forgot to show this slide. This was supposed to be before the demonstration, but basically with the help of Perun and EGI checkin, we can streamline the access to data and access to various tools, and later also to other aspects of EISCAT 3D operation, like time requests and key. And possibly if we organize Perun in a really good way, a virtual organization in a really good way, it might also help, for example, national communities to set up some of their things, some of their services or social connections with help of us and EGI checkin. So it can use the same authentication for access. And that would be all from me. It got quite long. I don't know if it wasn't a bit confusing, but thank you for your attention. And if there are any questions, you're welcome.
Thank you very much.